This is lesson 5-2, Patterns in Linear Functions.
Some vocabulary review for you. Pause the video at this point to see if you can answer these two questions. Independent variable is the variable that is not affected by the change in the other variable, whereas the dependent variable is the one that is affected by change of the other variable. If you need review of those two terms, please consult lesson 4-1. Here's some more vocabulary for you. Values of the independent variable are called inputs, whereas values of the dependent variable are called outputs. A function is a relationship that pairs each input value with exactly one output value. Think of every function like this. We take the input, put it into the function, and we receive an output. It's kind of like if you were to make some toast. Bread would be the input, the function would be the toaster, and the output would be toast. Input values are typically represented by x, where output values are typically represented by y. So therefore, x goes into the function and we get y. A linear function is a function whose graph is a non-vertical line. Linear functions increase or decrease on a consistent basis. That statement right there is probably the most important thing that you can remember from linear functions, that they increase or decrease on a consistent basis. So how do we find a linear function? First thing you should do is make a two-column table. One for x, one for y, or whatever your input and output will be. Decipher your pattern that's being formed. You should describe it in words. Form an equation or a function according to relationship. You need to ask yourself those two questions. What is the initial gap, or the amount when x equals 0, and what is the rate of change? Then, graph your function if necessary. Here's an example of representing a geometric relationship. In the diagram below, what is the relationship between the number of rectangles and the perimeter that is formed? Pause the video at this point to see if you can give yourself a chance to figure it out. So when we have one rectangle, the perimeter is 6. When we have two rectangles, the perimeter is 8. And 3 would have 10. What if we had x rectangles? We're going up by 2 every time, but that doesn't mean we could say x plus 2. The problem is that we're literally starting out with 4 every time. So 4 is our initial gap. Going up by 2 every time would be the change. That's the number that we put in front of x. So we have x rectangles. We have 2x plus 4 as the perimeter. So your relationship here is y equals 2x plus 4. Let's do an example of representing a linear function. First of all, we have to find out, is this a linear function? And describe the function in words, an equation, and a graph. Pause the video at this point to give yourself a chance to do the work. So the first question is this a linear function? Because we have consistent rise or consistent increase, it is a linear function. Describing it in words, as x goes up by 1, y goes up by 1, and there is an initial gap of 2. The equation would come from we adding the initial gap at the end and making y equal to x. So, y equals x plus 2. I graph the 4 points that I have in my table. As such, on the graph to the right, you can see the red dots, and then I connect the dots to create my linear function, as such. If you're having difficulty with this lesson, please contact your teacher in class.